Well, good morning again. Hopefully the tech conference is going well for everyone. I'd like to spend just a brief amount of time this morning giving you an update on where we stand in our development process, both short-term and some of the ideas that we have for longer-term development in GNU Radio. The GNU Radio project has the GNU Radio project has been releasing code on a semi-formal basis for 11 years now. And one of the things that we have fallen into is a process where we go in these about 2-year stages of developing code within a certain series of releases that all conform to a particular API. And we work very hard at managing the code merges and development tracks so that you as developers, when you write code that conforms to and uses a particular GNU Radio version, that you'll be able to continue getting bug fixes and new features during the course of that release. And so they typically go from about 1.5 years to 2 years in length. We released GNU Radio 3.7 right at GRCon16. So we are at the 2-year part, and we're working on GNU Radio 3.8. But let's see how this works. The idea is that within a GNU Radio release series, you can be confident that as you develop your applications, you can upgrade GNU Radio without finding out that all of a sudden we broke something that you had done and you have to go spend some unscheduled time to do that. It does put us in kind of an awkward position though, because it puts restrictions on what we can add into GNU Radio to keep our promise to you. Some of those restrictions are in the form of not being able to use new features, like when C++11 came out. Compilers took a long time to support that. And we have to make sure that GNU Radio can run on some baseline set of platforms and distro releases. We tend to follow what the distro developer supports, like Ubuntu has 12.04 still in LTS. So we support 12.04 and the packages that are available there. So in practice, during the course of about 2 years, we'll add a lot of new functionality, but we won't remove any. You'll see some overlapping things. You'll see multiple ways of doing something. You'll see code that people haven't used or maintained for a long time, but we won't remove it because then if somebody's relying on that and they upgrade to some new version of 3.7, for example, and then they'll find that we took away something that we said we wouldn't. So the end result of it is that as the release series gets older, we tend to accumulate a lot of cruft and overlapping features. When we go to a new major release series, what we'll do is remove all of that cruft and, well, not all of it, but as much as we can to give a fresh start for all of the new code that's being developed. The process here is very organized, very meticulous. And I'll contrast that with what we do on a major release. We tend to burn it all down. So in particular with GNU Radio 3.8, we're removing a lot of things that have been around for a long time and haven't been used. The last time I checked, we're removing about 10 times as many lines of code as we're adding in this release. So 3.8 will be a lot leaner, simpler, fewer choices, but they're choices that people weren't making anyway, because we find out that there's a bug in something and that bug's been there for 3 years and nobody noticed, which means nobody's using it. Now, seriously speaking though, with the GNU Radio 3.8 release, we're making several transitions to things that will impact you as developers writing GNU Radio applications. It'll impact you in the supported platforms that you have to use. It'll also open up new areas. In particular, probably the biggest transition we're going to make with GNU Radio 3.8 is the switch to Python 3. And this has been a long time in coming. Part of the reason for that is a lot of the Python dependencies that we rely on have taken a long time to get Python 3 support. And in some cases, never did. So we've had to change out some internals of GNU Radio so that we can use it on Python 3 because the packages we were depending on don't have Python 3 support at all. And that's part of the reason why this got a little complicated. Part of that transition is to switch our code generation engine from Cheetah to Mako. Cheetah is the one of those packages that never made it to Python 3. It's currently unmaintained, so we had to go and change out all of the machinery that converts GRC flow graph descriptions into generated Python code. And I'll talk about that more in another slide, and then you'll hear even more about that from Sebastian Koslowski a little bit later today. Another major change that we're going to be going through is we've removed the WX-GUI window system. Somebody suggested I get glass walls around the podium here. How many of you is that going to create large amounts of heartburn? All right, it's time to remove it. Sorry, Balin. It's interesting to see who's using the Qt stuff and who's using the WX stuff during the presentations, during the show. We're going to be doing a lot of work on the GUI system, which I'll talk about later in the presentation, and having to do that twice is sort of out of the question. So that's a big driver. Again, the 3.8 and every major release is an opportunity to clear out stuff that we don't want to commit to support for the next 2 years until we get to like 3.9. The removal of blocks that are either obsolete or they've been improved upon in other ways of doing things is particularly acute in our GR Digital set of blocks that we provide that help you implement digital comms type applications with GNU Radio, which is probably the most popular application that people use GNU Radio for. That's going to involve quite a bit of somewhat delicate surgery. We've started on that already. Nathan West is going to be helping sort of shepherd that process through for 3.8. I just put you on the spot, so he's not looking at me. So that's another area that you'll have to look at in your code is if you're using our digital comms type blocks, modulators and demodulators type of thing. What we'll see in 3.8 is going to be a lot simpler than all of the varied choices that have accumulated over the last several years inside GNU Radio. Some of the work that was done during the 3.7 series, Tom Rondeau, Sean Nolan, Andy Walls, Nick Foster, these are things that will become sort of the way to do things in 3.8, and all of the overlapping stuff will go away. We're going to be publishing more documentation on this process as 3.8 gets closer. The final thing that you'll see that's different is we're dropping support for older versions of lots of distros. For example, the Ubuntu 12.04 LTS is going out of support in a few months. Marcus is very happy about that. Things like Qt4, now Qt5, GTK2, GTK3, versions of Boost and CMake, the various things that we rely upon to either compile GNU Radio or to use at runtime. We can now clear out the requirement that we can't use newer features because then we'll use features that are on modern versions of the distros. Okay. Now the Python 3 support is a little complicated because we use Python in so many different ways. We have our, of course, GNU Radio Companion itself was written in Python. And that's going to be upgraded to work in either Python 2 or Python 3. The flow graphs that you can generate from GRC will support either 2 or 3, but I'll get to that in a minute. The wrappers to incorporate C++ blocks into your Python flow graphs, of course, will use Python 3 support in Swig. And then we have, I don't know, 80-some thousand lines of Python code in the tree that we have to upgrade to Python 3. And we'll be using something called the 6 compatibility library that you're probably familiar with. 6, 2 times 3, will give you the ability to write code that can run in either environment, and it abstracts the differences between them. It's a fairly lightweight library. We're using it for the GNU Radio Companion. We'll use it for the rest of this. The challenge is that we'll only be able to do one at a time, meaning you'll install GNU Radio for a Python 2 environment and be able to do stuff in Python 2, or you'll install it for a Python 3 environment and be able to do things for Python 3. but you won't be in a position where I can be in GRC and create a Python 2 app or a Python 3 app. It'll be for whatever the whole installation is for. We may look at trying to do the dual support, but that depends on resources that we have. How many of you are doing work now in Python with GNU Radio and feel constrained by not being able to do Python 3? Maybe I shouldn't have asked that. Raise your hand even further. Yeah. Okay. Part of this is also driven by the fact that most distros are switching to Python 3 as their default soon. Ubuntu in particular, I think 16.10 will be that way. And so we need to finally be able to make that transition. Again, Cheetah was a library that was used. When we do our Python code generation, we have a template process. It gathers the information that is supplied about the blocks that you're using in the GRC, flow graph description itself, and applies all this to these code templates that generate the Python script. Cheetah is no longer maintained, and it doesn't have a Python 3 version. We actually looked at perhaps taking that in and doing our own port of Cheetah to Python 3. But it turned out that we have a much better option using the Mako system. This is already in use in a couple of places. I think the Edis Research software is now using that as well. The Volk library, is Volk using Mako yet? Not yet. All right, so that'll be part of it. What that is also going to entail, though, is that the format for the block descriptor files, the GRC files that you have to write when you create your own blocks, are going to a new YAML-based format, and Sebastian will talk about that in more detail during his talk. It will mean that you'll have to do this for your existing out-of-tree modules. If you're using the mod tool software, it will generate all this for you, just as it does today with the XML format. But the existing ones, you'll have to manually make these changes. Now, we're going to provide a tool for this. We have to do it ourselves. I just counted the we have hundreds of XML files in the tree that we have to do to convert this. So we're doing this to automate ours. You'll have access to this to help automate yours. And again, Sebastian will talk more about this. Now, we're doing all of this 3.8 work in tree on the next branch. So if you follow our GitHub repository, you'll see we have the main, master, and next branches. We do our main current release series development on master, and we do the 3.8 or the next one on the next branch. So you can actually check out the next branch, compile it, and use it. We've never intentionally broken the, with all these changes, broken your ability to use it actually as a development environment. So you can get that and you can use it and you can start to see for 3.8 what you might have to do with your software. But not all the features are merged into it. The Python 3 Mako work is still being done, has not been merged in yet, and so that'll be a big change. But most of the rest of what we've talked about for 3.8 has already been done, and so you can see what the differences are for yourself. We're looking at end of the year, November, December timeframe. It's a little tricky because we have a lot of stuff coming together all at the very end, and so the testing and the integration of the different threads of code going on to make 3.8 are, again, all coming together at once. When we do that, we'll make a final 3.7.11 release. One of the things that we're doing in 3.7.11 is that anything that we're deprecating that won't be in 3.8, we will mark that in 3.7. So if you upgrade your installation to 3.7.11 and run your software, you'll see everywhere that you might have to do some change. The blocks in GRC will show deprecated, the Python scripts will show deprecated, that sort of thing. We're going to be starting a weekly development meeting. This is obviously open to the public, the way we do our monthly calls, but the entire focus on this will be inward. So people are welcome to participate and listen, but it's really a working meeting of the core devs working on 3.8. So once we all agree on when this is going to be, we'll set it out. And we'll make the Hangout again available for people to follow along and contribute if they like. But unlike the monthly call where it's more of an outbound communication, this is a working meeting for the development crew. Now I'll talk a little bit about how things, we see things moving going forward with GNU Radio, at least part of it. And one of our biggest challenges is, as an open source project, you don't develop a roadmap, establish a software development timeline, pick the engineers that have the right skills, and then pay them to go get it done. That's a commercial software environment. That sort of software engineering flow is, gives you visibility into what you want to accomplish. There's sort of a top-down process of deciding, product requirements, et cetera. In open source, a lot of it is what people are willing to work on. Most of the people involved in GNU Radio are unpaid volunteers. Our last release, we had contributors from 40 different people, from academia, from government, from commercial companies, from hobbyists. So the contributors from all over the world, but they're working on things that are important to them personally or things that they might be involved with in their professional occupation. But it's difficult to say, this is exactly what we're going to do. What happens instead is we try to set a theme. We say, this is where we want to see this to go, and we identify people that are interested in that. We look at what people are already doing and try to maybe grab that and bring that out into the project. So what I'm going to talk about are things that we'd like to do, but they're not necessarily things that we're going to do, absent unpaid volunteer work or funded development. This is the nature of open source. One of the challenges that we also face is that most of our users are not software developers. They're RF people. And so that sort of flow back and forth of contributions versus core developers is not quite as high as it is in other open source projects. Because a lot of people who are using GNU Radio don't write software for a living. They write software because they have to. The four areas of work that we see delivering on and starting work on inside the 3.8 series, our development tool set is one set of things. How the runtime software operates is another. The things that we supply to you that you can use for building your own applications. And then some of the examples that we give you to emulate or to learn how things work. These four areas are what we tend to focus on when we do long-range thinking and planning. I'm going to start with the runtime architecture. As GNU Radio has grown up and has been applied to different application requirements, we have found some friction in being able to deploy either scaled up to large heterogeneous systems or scaled down into embedded devices. And part of that is because the design of the software itself tends to be one application running on one PC, which is how things start typically. But as you want to implement signal processing in larger environments where you might have compute clusters or you might have multiple stages of operation, or you might need to integrate the signal processing into larger data flows happening elsewhere, it's difficult to do that. Also, in embedded machines, you typically don't develop on the embedded device. You develop in a cross environment and then deploy onto the device and run it. So this, one of the set of features that we want to enable in GNU Radio is to bring out the internals of GNU Radio blocks and flow graphs into a form that they can be manipulated remotely. We typically have properties or configuration parameters, we have streams, and we have message flows. And those are the kind of things that if we can bring those out into a form that you can manipulate more easily from outside an application, then you can use that to communicate between multiple devices. You can use that for management and monitoring. I'll talk about in a minute how we might use that within GRC. But it's a set of capabilities that we've sort of got with things like control port, and we have ZMQ blocks to do flows and messages. But it's really kind of ad hoc. And so one thing we'll be leading is a effort to bring this out as a formal design so that then you can write software on the other end of these messages and flows to interact with GNU radio flow graphs. Another one is a switch away from using the function call type GUI elements. If we can make our graphical interface elements and control of blocks done via messages, then where that message gets generated and where the block is running can be on opposite sides of the internet. As it is right now, our GUIs have to be in the same process and call functions to manipulate things. So by breaking this out, we'll be able to have interfaces to our software that run independently of the digital processing in the flow graph. And those can be on the same machine. They could be on two different machines in a data center. They could be separated by an internal or an external network. So this kind of distributed design is something we've wanted to do for a very long time. We're missing a lot of key elements, but finally with 3.8, we sort of have everything in place that we need in the runtime and in the rest of the software to start building this out. Our block library has evolved again over 10 or 12 years to have hundreds of classes and hundreds of blocks. And as we go through and we look at what are the common design patterns, out of something like 400 blocks that we have, maybe a fifth of them, 20%, are synchronous blocks that have one input and one output, no configuration parameters, and no constructor arguments. So that's like 50 classes where it could be one class with different work functions. Particularly as we start adding these new capabilities, what we want to do is to separate our DSP from the wrapper code and provide some common patterns that we've seen now over the years, so that when you write new blocks, you can write the DSP side and plug it into an already existing template that implements the pattern that you want. Now maybe your pattern's completely unique, so you'll be able to do what you do now. But what we're expecting is that when we start adding message passing for configuration and things like that, there'll probably be 10 common things that will work for 90% of the cases. And so we'll develop those, and then you can specialize those to implement what you want. And this is a little vague here because we haven't quite figured out the best way to do this. C++ does not make this easy. But we're hoping that this will actually reduce the amount of work that you need to do to create a new block, but getting the benefit of all these new features that we're talking about. Finally, we're probably going to get rid of tag stream blocks. Is Tim O'Shea here? I would expect to hear him cheering, but all right. Tag stream blocks were something that were implemented out of necessity because we didn't have message passing at the time. They work pretty well, but they're really hard to get right. And they tend to have these really odd corner cases. I say probably because we could probably fix them and make them work well. But we want to get to a point where we have a really good separation of stream flows and packet flows in the application design. And tag stream blocks are kind of halfway in between. So we're not entirely clear how useful it is as an abstraction. Now, if we get rid of this, it would be in 3.9. So it's part of 3.8, it's part of the API. But we're looking at what do we use it for. Well, we'll talk to users and see what they're using it for. And if it's something that isn't particularly useful in the end, and we have better ways of doing it using pure packet flows via messages or stream flows with just the generic streaming, then that's another thing to slash and burn for 3.9. And it's less code we have to maintain going forward. Who's using tag stream blocks? Oh, maybe we shouldn't. Now this is the big idea that I'll talk on Friday during the Hackfest on what this might look like. We really want to get away from having GRC be a Python script generator and much more of an interactive flow graph design tool. So we're looking at what will be needed to turn GRC from I connect a bunch of blocks, I configure them, I hit play, out spits a Python program and it runs, And then if I want to make a change, I stop it, I go back, make my change, I generate the code again, and I run it. That kind of iteration can take a long time, and it also means that you're running it on your own machine. But if we have those runtime features that we described in the previous slide, you can actually build an application that is talking to a running flow graph. And when you add a block, it adds the block in real time to the existing flow graph. And when you want to probe a flow or a set of messages, instead of it printing on standard out, we can build instrumentation to see how this is going. I like to think of it as like a GDB, but for flow graphs that are running. And so GRC then would move to more of a runtime environment. You wouldn't need it to run the app, but you would have a full visual way of looking at performance counters and things like that. Obviously, this is quite a bit of work. It's something that we're long on vision, but short on developers to do. We may look for formal funding for this. We may look at soliciting some of the work that's required to implement this as sub-projects that we can get funding from whatever entities to do. I do think, though, that this kind of instant feedback and development will make experimenting and productivity in GNU Radio go way up. Because it's like the compile debug cycle in C++. That iteration time takes a long time. It's even worse like with FPGAs, with synthesis and all of that. But if you can, drop blocks on your flow graph while it's running and look at the results of what you've done, and you can change parameters in real time, and you can probe flows and all of that, that is something that we think will really make a big difference for you. So we'll talk more on Friday about how that might look and how you can get involved. The last thing I'll mention is it's a common refrain that we hear that we don't have enough examples. That when people start to use GNU Radio and they want to look at what other people have done or how we tell them to do things, we don't have nearly enough well-implemented, maintained by the project, distributed by the project type applications that you can refer to see that. And so we'll be starting an effort to formalize doing reference designs in GNU Radio. They won't be in Tree, they'll be part of the GNU Radio project, but they'll be their own application with their own issue tracking and their own developer leads and that sort of thing. But we're hoping that we can demystify some of the common problems that we're seeing with new developers coming into GNU Radio. And they know what they need to do, they have no idea, sort of like the first step of how would you implement an application that does burst communications? How would you do an application that has some kind of ACK-NACK protocol between packets? How would you do spread spectrum synchronization? There's just lots of different things that once you sort of get past that first hurdle of going, oh, I see how that's done, now it all falls together in your mind. And that's our goal, is to make that happen a lot more frequently. Now again, everything I've talked about are things that we can't write a product requirements doc and hand it off to engineering and they develop a plan and say it's going to cost this much money, and then everyone goes and does it and QA tests it and we release it. I come out of the commercial software world, so that's a software engineering life cycle I'm quite familiar with. You can't do that in open source. You can provide an environment where people are happy to contribute. You can solicit funding. You can rely on people to share what they've done. But what you can't say is, you will do this. What you can say is, if you did this, it would be really cool. And then they agree and they go do it. Or you give them money. I don't know how much time we have. Probably have time for some questions, maybe? All right.
Oh, there we go. All right, do we have any questions for Johnathan? Or just about GNU Radio organization project in general? All right, we have a few back here. Jose.
When it goes from XML to, I think it was Mako for the GRC blocks, are you going to update the guided tutorials or the other tutorials?
Yeah, we'll have
quickly?
to.
Okay.
That was an easy one. If there's anything about the Python stuff that's hard, I'll refer to Sebastian.
Or over here. All right, Martin's up next.
So this question was actually, I'm relaying this question from various sources. When you mentioned the dependencies, is there any mention, planning of supporting C++11?
We will do that the moment that it's available in compilers in all of our supported platforms. The moment we add features using C++11, we exclude anyone working on platforms that don't have that in their compiler. Now that's actually pretty close. I haven't done the formal survey. That's probably something that we should be doing soon. But until then, that's the criteria. We don't do it because we don't like C++11. We do it because we support certain platforms for users. We promise that their software will always work on that platform. And if we merge something in and all of a sudden their compiler chokes because we use some feature it doesn't support, that's a bad situation. That's the only reason why. I'll be very happy when we can upgrade, particularly some of the code I wrote 10 years ago, to use some modern features of compilers that are available now versus 2007.
One second, Sebastian. I think we have one over here, and then Sebastian, and then somebody could get a mic to Stu afterwards. Thanks.
Are there any plans for complex short support?
I'm sorry, one more time?
Complex short, so that you're having a more compact way to communicate with high bandwidth
So
ZRs.
I think the question is, well, so right now in GNU Radio, most of the data flows are complex IQ using single precision floats. Very common data comes from digitizers as, Q.15 complex shorts. It's a challenge for us because floating point is so easy. When you do fixed point now, you've got to worry about ranging and overflow and how to deal with bit growth and things like that. We probably will not see that anytime soon. That said, and this is the classic response, we'll merge patches. That is, it's a lot more work than it sounds. We typically deal with floating point, and because we don't have dynamic range requirements that are so high, if you've got 60 dB dynamic range requirements, you're doing something kind of unusual. So we tend not to run into the bad parts of dealing with floating point, because we're not doing huge differences in magnitudes of numbers. So really, if you convert from complex shorts to complex floats, as most of the driver software does, like UHD, you tend not to get in any trouble. That's kind of a weasel answer, but that's the way it is.
Sebastian?
Yes, with 3.8 coming and breaking changes, of course, can you maybe comment on the life cycle that 3.7 will have after 3.8 is released? How long will we make updates? Give people time to move.
So the question is, what are we going to do about 3.7? Because we have 3.8 and it's going to be so different. Some of this is going to be up to Nathan to decide, because he'll be doing the work. But I expect we'll have a 3.7.11, and then if there are serious bugs that are reported after that, we might have the the fourth digit releases as maintenance fixes on that. But that's not. There's no intent to do like a 3.7.12 or to continue developing the 3.7 branch, if that's what you're asking. There may be bug fixes published to that, but we'll make a pretty clean break into 3.8. Again, though, this is really no longer my decision to make, so that could turn out differently.
Stu?
So exposing some of the structures more explicitly and making greater use of 0MQ, do you see that as potentially facilitating federated architectures where I could pipe a stream out of GNU Radio over to MATLAB or LabVIEW or some other whatever, and then maybe pipe it right back into GNU Radio?
Absolutely. That's exactly, well, not exactly, but one of the major reasons why we want to do this. Let me go back to that slide real quick. Message flows, stream flows, and property, pub sub, subscriptions and updates, these can all be defined in a way using something like Protobufs probably, so that in other software that's not GNU Radio, you can write endpoints that talk to these in whatever language you want, in whatever application you want. The idea is that the GNU Radio app doesn't know what's outside of it, but what's wrong, the wire format would be standardized and documented so that you could then get data into and out of GNU Radio in a well-defined way. Now we have this capability now with the ZMQ blocks, but Our wire format's kind of homegrown, and it's not hard. It only takes like 5 lines of Python to unmarshal things. But we have to rethink how we deal with PMTs and compound data objects and all of that. Was that the answer you wanted to hear? Okay, good.
Awesome. Any other questions?
Is this on? Yep. So has there been any discussion about releasing GNU Radio as sort of a flat pack or something more monolithic where it incorporates all of the dependencies and such?
I think what you're asking is, right now, GNU Radio has a bunch of dependencies. Different distributions handle it differently, and so you have packaging systems that are supposed to help you with that. They usually do.
I found about 1 in 3 times it does.
I'm sorry?
I found about 1 in 3 times it does help.
Yeah. We really don't want to get into the kind of situation where we're trying to outthink what the distro maintainers do, because they're familiar with their environments, they're familiar with the things that change around it that we don't know. There's a lot of things we depend on. So I think if we were to absorb that and try to deliver something that was sort of monolithic, we'd be reinventing a lot of stuff badly. That's my personal opinion. That being said, there's some stuff that we're looking at with Docker that I haven't talked about to make some things available as binary blobs in the Docker format.
I'd like to comment on that as well, but I see Maitland has a mic. So I'm hand it over to our Debian maintainer here for a second.
So bug reports on Debian package are welcome. I haven't gotten nearly enough of them. Maybe there should be some more coming. And then that flows into other distributions as they see the visibility from Debian.
So just to add a little bit more color to that, things like Flatpak, there's one competing, I can't remember, there's one actually from GNU. I don't remember if that's Flatpak or the other one. Snaps, maybe is what it's called.
Snaps, yeah. A bunch
yeah,
of
and then obviously there's container things like Docker. Like Johnathan said, we want to make sure that we're not interfering with the official distribution maintainers' flows. Those kinds of things are really awesome for delivering applications that depend on GNU Radio. So if you're like delivering a product and GNU Radio is part of your product, and you want to deliver one thing without having to worry about everything, you can containerize all of it and just deploy it. And those have been really great, and I've seen a lot of people using those kinds of containers for that sort of workflow. And we've had some discussion on the list about Docker, as Johnathan mentioned, but yeah, we haven't, not aware of a way right now to integrate those as a default integration workflow without sort of messing up other stuff.
I don't know how much time we have. Keep going as long as you want.
We have a couple minutes. Yeah, we have a couple minutes, but it'd be great if Mike Osmond could come up and start getting set up.
Okay, I have a question about the what you said about the stream tag blocks. You said basically it's you want to make clear separation between streaming blocks, streaming flows, and packet flows. And I think the stream tags is something very useful because we need something in between. And I'm worrying if you want to remove that. So,
all right. So the comment and the question is that we have this thing called tag stream blocks that I said we might remove, and you're worried because they're useful to you. In fact, they provide sort of an abstraction of packets over these streaming flows. So we're not getting rid of stream tags. Those are very useful for annotating flows. They can be used, for adding metadata, and you can use them to represent, stages of processing and job control and all sorts of things. Those aren't going away if that's what you were thinking. Tag stream blocks were an attempt to use the stream tag mechanism to do bounded processing, where your work function could be guaranteed that the entire thing was sitting in memory. It works. We have an OFDM reference design that uses it. They just are hard to get right. And part of it is, there's a finite amount of memory in buffers, and so you can't go over a certain size, but it's hard to figure out what that buffer size is. Part of it is just the accounting that has to go on and the state you have to keep. So they work. They're hard to use. They're especially hard to get right. And we're not sure if they're worth the effort of maintaining. But we're not getting rid of stream tags. It kind of sounds like that's what you're worried about. I lost the original questioner.
Yeah, I think you're right. I think it's more like stream tags.
Yeah, so stream tags are not going away. We use stream tags to do this TSB abstraction. So the TSB abstraction we think might go, but not stream tags.
All right, I think we're out of time, so let's thank Johnathan. And, So while Mike's getting set up, I have a few announcements. Dr. Mark Platt, you are the winner of the CU Boulder drawing. Woo, awesome. So head back by the CU Boulder booth and you can pick up your swag. For everyone else, CU Boulder's running a drawing every day. If you go by their booth in the vendor room, you can drop your business card and you'll win sweatshirts or t-shirts or, Therese, is it clothing? Yes, okay, cool swag. A couple other items, again, just to re-announce it, I really like to keep these doors unlocked so people can go in and out during the break periods because they're very useful, but please refrain from going in and out of those during the talks. They're very noisy, and I didn't bring any WD-40. And thanks, Nick. Third, some people have been asking about the area that the reception's in tonight. So the downtown area in Boulder, if you haven't been there yet, is actually really awesome. It's a really cute downtown area with lots of shops and little restaurants and stuff. So yeah, if you want to head out after the reception instead of hanging around for trivia night, there's tons of stuff to do in the area, or just get there early. So my mic's setting up. I'm actually going to add one more thing to the Docker question. I'm going back to that. Oh, Terry, you were the one who asked the question. So your question was specifically, I think, about methods of installing GNU Radio. I think one of the things that those kinds of containers are extremely useful for are getting people up and running very quickly who don't care about doing development. So something like, I mean, previously software distributions like GNU Radio would distribute virtual boxes, right? And you would download the whole virtual box and load it, and you have all your stuff. Now Johnathan sponsored live USB drives that should be in everyone's attendee bags, right? So you can plug those in and use them and not have to worry about installing Linux and all that kind of thing. So I think those are really great. I've not used Flatpak or Snaps yet. Docker does. You do have to have the expertise to get Docker running on your machine and then actually deploy the Docker container. If Flatpaks and Snaps are a little bit easier, those could be better. So outside of the installation for development purposes use, I think those could be very useful for new users. So it comes down to having the time to invest and maintain those kinds of images.